In this video, we're going to look at decimal and binary numbers. Now, decimal notation is what we're most familiar with. And this is based on the sums of numbers of the form C, where C's are constant, times 10 to the n, where n is an integer. In fact, we're mostly going to be dealing with non-negative integers n in this episode. Again, and C's are constants. And let's just do a quick example. Suppose we have the number 8431. This is really like 8,000 plus 400 plus 30 plus 1, which can be written as 8 times 1,000, or 10 to the third, plus 4 times 100, which is 10 squared, 3 times 10 to the first, plus 1 times 10 to the 0 power. That's kind of where we get our numbering system. We're taking sums of powers of 10 to integers. And then what we have in the numbers we come up with are actually the coefficients of each of those powers of 10. And let's do another one real quickly. 709 can be written as 700 plus, now notice there's no tens. Let me just rate that as 0 for the moment. Plus 9. So this is like 7 times 10 squared plus 0 times 10 to the first plus 9 times 10 to the 0. So that's our decimal system, which we use all the time. Now the binary system is based on powers of 2. This was based on powers of 10. The binary numbers are based on powers of 2. Binary representation of numbers is based on the sums of numbers of the form C, once again, some constant, times 2 to the n, where n The n's are integers. And once again, the c's are constants. And we'll have to sort of keep in mind what powers of 2, what are they? And let's maybe make a little table. You can either start from the left or from the right. I'll probably, let me just maybe start it from the right, since often that's how we're going to be writing our binary numbers. So let's 2 to the 0. What value is that? That's, of course, 1. To the first power is 2. To the second power is 4. To the third power is 8. To the fourth power is 16. To the fifth power is 32. To the sixth power is 64. To the seventh power is 128. That's probably all we need for the moment, but you can continue on as far as you like. But again, when you're working with binary numbers, you're working with powers of 2. So instead of working with, say, 1, 10, 100, 1,000, 10,000, etc., we're going to be working with 1, 2, 4, 8, 16, 32, 64, etc. So let's sort of just jump into some examples. So suppose you want to convert numbers, decimal numbers, to binary numbers. With, let me say, the decimal number. (47) into binary form. Let's go ahead and start. And again, you don't have to usually be all this meticulous as I'm going to be, but I'm going to go through all the steps just to be sure you understand. Like I say, when you're actually writing out, you don't need to do all these steps. So the first thing you want to do is find out what the biggest power of 2 is that you can take out of 47. So, of course, if you look at our chart up here, 64 is bigger, but 32 is smaller. So it's between 32 and 64. So we can take out 32. And then what's left? 15. So I took out the biggest power of 2 I could, and then added on whatever was left over. So this is the power of 2 now. So do the same thing with 15. On the next step, we're going to find what's the biggest power of 2 that we can take out of 15. Of course, if you look up here, 16 is bigger, so we can't take that out. So just below 15 is 8. So let's take that out. Again, I'm working with 15 now. And then what's left over is 7. So this is the power 2. This is the power 2. Now keep going. Do the same thing with 7. So what's the biggest power 2 we can take out of 7? 8 is bigger, but so 4 is going to be the biggest one. So 4. And then what's left over is 3. So again, this, and this are all powers of 2. So let's take, what can we take out of 3? Obviously, the biggest power of 3 that we can take out, excuse me, the biggest power of 2 that we can take out of 3 is going to be 2. And then we're left with 1. Now, as soon as you get everything in the powers of 2, you can stop, because these are all powers of 2. There's 2 to the 0, to the first, squared, third, etc. So now let's write those as powers. So this is 2, what is this? 2 to the 5th. I'm going to have to push this up a little bit. And this is 2 to the 3rd, 2 squared, to the 1st, to the 0. Now, when we're doing this, we have to include, much like we did previously, we're dealing with powers of 10. We want to include all the powers of 2. So we'll put zeros besides any ones that haven't been included. So let's write this out. So this is going to be maybe like 1 times 2 to the 5th. And then notice we don't have a power of 4, so it's going to be 0 times 2 to the 4th. 1 times 2 cubed. 1 times 2 squared. 1 times 2 to the 1st. 1 times 2 to the 0. So once we've included all the powers and the proper coefficients, again, for the binary system, the coefficients are just going to be 0 and 1. And so now we can write this as 1, 0, 1, 1, 1, 1. And usually you put a little 2 here to show that these are the base 2. Let me just do a couple more examples real quickly. Once again, let me keep the numbers right here. And put 71 again, decimal number in binary form. And so solution, just like before, 71 is going to be equal, take the biggest value, the biggest power of 2 out of it. Again, 64 would be the biggest number you could take out. Just 64. And then what's left over is 7. So again, this is a power of 2. So go to this one. What's the biggest power of 2 you can take out of it? Obviously, it looks like it's 4. And then what's left over is 3. So these are powers of 2. What's the biggest power of 2 you can take out of 3? That's going to be 2. And what's left over is 1. And just like before, what do we have? This is what 2 to the 6th time. 2 squared. Excuse me. 2 squared. To the 1st. 2 to the 0. And this is 2 to the 6. And so you have to include all the ones, all the powers of 2 that are on here and put zeros in front of them. That's 2 to the 5th. 0 times 2 to the 4th. 0 times 2 to the 3rd. Then we do have 1 times 2 squared. 1 10 to the first plus 1 to the 0. And so again, write out all these coefficients. So it's going to be 1, 0, 0, 0, 1, 1, 1, and put a little 2 there. I'll do one more quick example just to be sure we're on the same page. Rate 98 in binary form. Once again, what's the biggest power of 2? It's going to be 64. And we take 64 out of this. What's left over? What is that? 34? So this 64 is the power of 2. Now go over here. What's the biggest power of 2 you can take out of this? Looks like 32. Now, this time already we have everything as powers of 2, huh? So we can just write those down. 2 to the 6th, 2 to the 5th, to the first power. So it's 1 to the 6th, 1 to the 5th. And include all the powers of 2 that weren't in here and put zeros in front of them. So 2 squared to the first, 0, 2 to the 0 like this. And so this is going to be, write these values down, 1, 1, 0, 0, 0, 1, 0. And put a little 2 there to show that these are binary numbers. Now let's go in the other direction. Let's write binary numbers in decimal form. Write the binary number 10101 in decimal form. And let's write that out. So again, all we have to do is multiply these coefficients to all the powers of 2. So, and we usually have to start on the right-hand side because sometimes we don't know where it ends. You could count and see what this one is, but it's usually safer just to start on the right-hand side. So we know the first one is going to be 2 to the 0 power. And that's times 1. The next one is 0 times 2 to the first. 1 times 2 to the second. 0 times 2 to the third. 1 times 2 to the fourth. 0 times 2 to the fifth. Make a little bit of room here. And 1 times 2 to the sixth. Hopefully you can see that. So again, all I did was started here. This to the first, excuse me, to the 0, to first, to the second, so on and so forth. And then wrote the coefficients down. And then what are we going to have? This is going to be 64 plus 0 plus 2 to the fourth is what, 16 plus 0 plus 4 plus 0 plus 1. And this is going to be 85, like that. And again, let's do just one more. And so write 110112 in decimal form. One one oh one one two. Again, start over here in the far right. We know that that's 2 to the 0 power. Next one is 2 to the first. And 2 squared. 2 cubed. 2 to the fourth power. That's going to be 16 plus 8 plus 0 plus 2 plus 1. And then just add these up. That's going to be 10, 26, 27, like this. And that's converting binary numbers to decimal form. Next, we're going to consider adding and subtracting binary numbers. But first, we're going to review by adding and subtracting decimal numbers, because sometimes we can forget this since we use our calculators so much. So let's say you want to add 2 decimal numbers. If you recall, if you want to add these 2 numbers, start over here. So this is going to be 16, and we carry the 1. And then add this, and that's 15, and carry the 1. And add this, and that's 6. 656. And suppose we want to add these 2 numbers. $746 and $389. Again, add the first ones here with that 15. Carry the 1. And that's 1213. Carry the 1. And that's 11. Like this. So again, I want to review this because we are going to In a little while, I'll do this with binary numbers. So let's subtract. Let's start with 543 and subtract 89 from that. Now, if we try to subtract here, of course, 3 is much smaller than 9, so we're going to have to borrow from the next number. So again, we're going to cut this down to 3. And of course, remember with decimal numbers, you're always borrowing 10. So if we borrow something from here, we're actually borrowing 10. So it's going to make 3 plus 10, which is 13. So we're going to take 13 minus 9, which is 4. Then go over here. Once again, 3 is much smaller than 8, so we're going to have to borrow from this guy here. So bring that down to 4 and bring 10 over here. So we subtract this. 13 minus 8 is 5. And of course, over here we have 4 minus 0, which is going to be 4. So we get 454. And again, let's do one more. Let's take 1,000 minus 647. So again, 0, of course, is much smaller than 7, so we have to borrow, but can't borrow anything from that. So if you go to the next one, can't borrow anything from that. We have to go to this last one here. Again, we're going to have to take one of these, we make it 0. We're going to, again, bring 10 over to here. But again, remember, we have to supply something up here, so we have to go all the way across. So again, we have to cut this down to 9 and bring a 10 over here. And finally cut this one down to 9 and bring the 10 here. So 10 minus 7 is going to give us 3. Then 9 minus 4 is going to give us 5. 9 minus 6 is going to give us 3. That was a review of subtracting decimal numbers. But how about binary? The idea is pretty much the same. And let's just see what we end up having. So let's go over here. And let's do this. Suppose you want to add this binary number to this binary number. Of course, remember, binary numbers, you only have zeros and ones. So again, over here, if we're adding these two together, you're going to get a 2. But of course, the most you can have is 1, so you have to carry over that 1 over to here. And once again, over here, you have 2. So you have to carry that over to here. Once again, over here, you have 2, which is 0. Carry this over here. Again, you have 2. Carry this over here. Finally, you have this. Because remember, before, anytime we had something 10 or greater, we had to carry, it over to the next one. So same thing with binary. So let's do another one here. Let's try this one. Let's try 1, 1, 2. Let's add these two numbers together. The same numbers. So 1 plus 1 is going to give us 2. So it's going to be a 0. Carry the 1. But now notice this time over here, we're going to get 3. So of course, that means we're going to have like a 2 plus 1. So we can, so it'll give us a 1 here. And then carry the 1 over here. And once again, we add these. We're going to get that's going to be a 1. Carry the 1 over here. And that's going to give us this. So again, the idea over here is when we added these two together, we got 2. But of course, that the most you can have is zeros or 1s. So 2 means you're going to carry a 1 over here and make this 0. So bring us back to 0 and carry that 1 over here. Now over here, we had 3. So we'll carry the 2 over, but we'll be left with a 1 here. And add these. You have, once again, you get 3. So you'll carry a 1 over for the 2. You'll be left with 1 here. You get this. Just out of curiosity, let's check this one. So let's see what we actually have here. Again, over here, this is going to be 2 to the 0 power. So it's going to be 1 to the first power, 2 squared. So that's going to be 4 plus 2 plus 1. So that's 7. And down here, that's the same number. 7 plus 7 is 14. Again, I converted it to decimal. Now let's convert the 14 back to binary numbers. So again, that 14 is going to be an 8 plus 6. 8 plus 4 plus 2. So that's going to be what? 2 cubed, 2 squared to the first power. And there's no 1 there. So this is going to be like a 1, 2 cubed, 1, 2 squared, 1 to the first, 0 to the 0. Remember, you have to include these all. And so that's going to give you 1, 1, 1, 0, like that, which is what we got over here. So it was just a check. I converted these to decimal numbers, added them, then converted them back. So what about subtraction? How do we handle that? Suppose we have something, an example like this. A 1, 0, 1, 0, 0 minus 1, 1, 0, 1. So just like when decimals, when we try to take 1 from 0, we can't do it, so we have to borrow. Can't borrow from this guy. We have to go over here, so we're going to borrow from this one. So that's going to go down to 0. And remember, when we're dealing with decimal numbers, we would bring a 10 over. But when you're dealing with binary numbers, you're going to bring a 2 over. And again, to borrow, we want to borrow 1 from that. And once again, you're going to bring a 2 over. So again, 2 minus 1 is 1. 1 minus 0 is 1. Now over here, once again, we can't do this one. So we have to borrow again. Can't borrow from this guy. Go over to here. This is going to be a 0. This is going to be a 2. Borrow 1 from this. Gives you a 1. And then we'll bring a 2 over here. And so 2 minus 1 is 1. And over here, 1 minus 1 is 0. And let's do another one. Let's do 1, 0, 1, 1, 0, 1. Again, these are all base 2. I should be putting a little 2 down here. And subtract from that 1, 1, 0, 0, 1. Once again, subtract 1 from 1, get 0. And over here, we can't do this. We have to borrow. And make that a 2. Remember, you always borrow 2 when you're dealing with binaries. So 2 minus 1 is 1. 0 minus 0 is 0. 1 minus 0 is 1. Once again, over here, we have to borrow. And that's 2 minus 1 is 1. And put a little base 2 here. Next, we're going to take a look at hexadecimal notation. Hexadecimal notation has sums of the form C16n, much like before, n is an integer. And C's, once again, are the constants. And one thing, again, because this is to the power of n, we're going to, excuse me, to the powers of 16, we're going to need some different notation. So again, let's go back to, say, decimal numbers and hexadecimal. And so this is going to be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And then for the hexadecimals, that's going to correspond to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we get to start with 10. We're going to have A, 11 is B, 12 is C, 13 is D, 14 is E, and 15 is F. And then we're also going to have to keep track of the fact that, say, if you have, say, decimal, hexadecimal. So again, if you have, let's say, 16 to the 0 power, that's going to be 1 in the decimal numbers. Of course, 16 to the first power is going to be 16. 16 squared is going to be 256. Again, the conversions work similar in a similar way as the binary. Remember, you had 2 to the 0, 2 to the first, 2 squared, etc. Except with 16, these numbers get very large very quickly. And 16 cubed is 4096. And 16 to the fourth. And we're probably not going to go anywhere near these large numbers, but let me just write a couple of them down. 5, 5, 36. So we have this system here. So let's just jump right in and convert numbers. So suppose you have a hexadecimal number. Convert the hexadecimal. Say 4 B E. Again, this is base 16 to decimal. So again, just to make that conversion, just go ahead and go through, see what this means. This means, so 4 B E 16. And again, these are so short, you could probably start from the left or the right, but let me start with the right as we normally did before. So this is saying E, and what E corresponds to 14. And so that's going to be 14. And since this is in the first place, that's going to be 16 to the 0 power. Then the next one is B. That corresponds to 11. And that's in the next position, which is 16 to the first power. And then finally, the last one is 4, and that's in this 16 squared. Like this. So let's give 4 times 256 plus 11 times 16. plus 14 times 1. And we may have to use the calculator to work this one out. Is 1024 plus 176 plus 14. And that's 1214 in decimal form. Again, if you want to put a little base 10 here, you can. Usually we assume if there's no number there, it's going to be decimals, but we'll put it there just to make it clear. And again, let me do just one more very quickly. Convert the decimal number A7D to decimal. A7D is going to be, again, D corresponded to 13. So we're going to have over on the right, we have 13. And that's in the first position. That's 16 to the 0 power. The next one is 7. That times 16 to the first power. Next one is A. A corresponds to 10. Like this. Of course, 16 squared is 256. 7 times 16 is 112. And of course, this is 13 times 16 to the 0 power. And this is going to be 2685 to the base 10. Now let's convert hexadecimal notation to binary notation. Let's pick number here. Let me pick the one I used, a 7D16. Convert this to binary notation. And so the main way you do this is to write each number as a 4-digit binary number. So, of course, first of all, let's see what each of these is. Of course, D, as you recall, is 13. So keep that in mind that D is 13. And that's 7, obviously. And then A was 10. So now write each of these numbers as a 4-digit binary. So again, 13, if we want to write it as a 4-digit binary, we're going to need an 8. And we're going to need a 4. Don't need a 2, need a 1. So again, this is 8 plus 4 is 12, plus 1 is 13 in binary notation. Over here, write this is binary notation. Again, the first digit's an 8. And we're going to need a 4, a 3, and a 1. 4, excuse me, 4, a 2, and a 1. 4 plus 2 is 6, plus 1 is 7. Then over here, we have a 10. So we're going to need an 8 and a 2. Like this. So again, we took each number and wrote it as a 4-digit binary number. So we have this. And so your final answer, we just put all those together. Base 2. And that's the answer. Let's do another one. Convert 6 E 0 A to binary. So once again, just take each one of these. Let me just write it down for clarity. Again, remember A is 10. 0 is obviously 0. E was 14. 6 obviously is 6. Then just write each of these out in 4-digit binary. So for a 10, we're going to need an 8 and a 2. So remember, this is 2 cubed, which is 8. There's 2 the first power, which is 2. The middle one is 0. So obviously, we just have 4 zeros. Over here, we have 14, which is an 8. And let's see, we're going to need a 4. And we need a 2. Let's just double check out. That's 8 plus 4 is 12. Plus 2 is 14. Finally, over here, I have a 6. That's going to be a 4 and a 2. And that's our number. Again, just double check. That's 10, 0, 8, 12, 14, 4 plus 2, 6. That looks correct. And again, you could probably leave it like that and put a little 2 at the end, just for clarity. Let me just write it this way. Like this, just be sure I got the right number. And that looks correct. That's converting hexadecimal to binary. Just write each number as a 4-digit binary number. Not surprisingly, going the other direction is pretty much just the reverse. Let me just pick 1, 0, 1, 1, 1, 0, 0, 1, 0, 1, like this. Convert to hexadecimal. So this time we kind of just do just the opposite. We take our number, and let me be sure I copied it correctly. I think I did. And then set it off in groups of 4. So here's the first 4, the second 4. And now there's not 4 here, so let's just add the 0 in front. Remember, if you add a 0 in front, it doesn't make any difference. So I just rewrote these in groups of 4 and put a 0 in front of that just so I have 4 here. So now go through and convert these to hexadecimal. So first see what we have. This is going to be 8 plus 2 is 10, plus 1 is going to be 11. Over here, this is going to be 8 plus 4, which is 12. And over here, this is going to be 4 plus 1 is 5. So let's just double check these. So that's 8 plus 2 is 10, plus 1 more is 11. 8 plus 4 is 12. 4 and 1 is 5. So again, what is 11 in hexadecimal? That's going to be B. What's 12 in hexadecimal? That's going to be C. And 5 is just 5. So that's our hexadecimal number. And just so you have one more example, let me do this convert. Convert this to hexadecimal. And again, let me just work with this so I don't make a mistake of copying incorrectly. So there's the first 4. There's the next 4. There's the next 4. Notice when you mark these out, always start on the right side. And there's the last 4. Happened to be there was all 4s here. Remember, if this last one has maybe 1 here, then you have to add 3 zeros in front. If there's 2 positions here, you have to add 2 zeros. or if there's 3 here, you may have to add 1 0 like we did in the last example. This time, they all came out in groups of 4. And so let's see what this is. This is 8 plus 4 is 12. And what that's just 8, huh? And this is 4 plus 2 is 6. And this is 8 plus 4 is 12. Plus 2 is 14. That's going to be 15. So again, double check. That's 12, 8, 6, 15. And again, let's write these down. 12 here. Of course, that's going to be C. 8, of course, is just going to be 8. 6 will be just 6. And 15 will be F. So that's going to be our conversion to hexadecimal.